Now, as I told you the other day, the genes that we work with, the resistance genes that we work with, now we've mapped a lot of them. We know the genotypes they occur in, and they often give a typical low infection type. All right, so for example, SR24 typically gives a 2 infection type. We never see SR24 on its own giving a Fleck reaction. It typically gives a 2. It might be a 2 plus, it might be a 2 minus or a 2 double minus, but it's typically a 2. It's never a Fleck. All right? Conversely, if we look at SR6, it's a typical immunity gene or a Fleck gene. It doesn't give a 2 infection type. If it's present on its own and it's challenged with an avirulent pathotype, it typically gives a Fleck. So if you can remember those, you work with these rusts and you work with these genes for a long time, you get to know this. I know that SR26 typically gives a 1-2 minus infection type. I know that SR27 gives a 1 infection type. If you work with these genes for a long time, you get to know them pretty well, and you get to know the typical low infection types, and that then helps interpret what you're seeing when you're looking at rust on different wheat varieties or different genotypes or differentials. So let's come back now to the original Steakman differentials. These were the wheat genotypes that Dr. Steakman identified originally as having good discrimination ability in separating different or identifying different races of stem rust. All right, didn't know what genes were present in them. Now we do. We've done the genetics, we've mapped these genes, and we know where many of them occur in the genome. Right, so Little Club, for instance, as far as we can tell, to wheat stem rust, has no resistance gene. Marquis carries SR7b, but it also carries SR18, 19, 20 and SRX. So here you have a differential that we're using that carries 5 resistance genes. That makes it pretty tricky when you're working with it. But in Australia, we don't have any isolates that are avirulent on any of these genes. All of our stem rust pathotypes that we identified, is it getting darker in here?
Yes.
Okay, it's not my imagination.
Sorry, I was trying to get...
Okay,
It's okay.
that's all right. So in essence, whilst Marquis has 5 resistance genes, we don't see these in Australia because all of our wheat stem rust pathotypes are virulent on them. So it is in essence a single gene line for SR7b. Right? Reliance is the SR5 differential, but it also carries SR16. And again, we don't have any pathotypes of stem rust in Australia low or avirulent on SR16. So it is essentially a differential genotype for the resistance gene SR5. And so on. You can see these other ones down here. Now these you can see are alleles at this SR9 locus. We were talking about this yesterday. Some of these actually have the same. So Arnott, Comindum and Spelmar actually have the same resistance gene in them. So there's really very little value in including all 3 of those in a differential set. But nonetheless, they are different alleles, and here's SR9E down here. I think we said yesterday we're up to SR9H, so there are something like 7 or 8 alleles at the SR9 locus. 3 of those are represented in the Steakman differentials, 9D, 9G and 9E. SR21 in einkorn, and then Kapley-Emma, SR7A, 13 and 14. Now in my lab, we don't use this differential anymore. For SR13, we use a thing called line S. So anyway, the point I'm making there is that when Steakman first started doing his work and he found these differentials could discriminate between different isolates of stem rust, he didn't know what the genetic basis of that of the resistance was in the host. We now know that. So what we do now is we report pathotypes. We identify pathotypes based on their virulence for specific genes, not genotypes. And to illustrate what I mean by that, if we look at this table I just showed you before, we could say, if we did the genetics, that differential number 1 carries gene A, differential 2 carries gene B, and maybe differential 3 carries both of those genes. So now instead of saying that isolate 1 is avirulent on all of those lines, we can say that it is avirulent for both genes A and B. So we're now reporting the pathogenicity, the virulence or the avirulence in relation to a specific gene. Now, I've mentioned infection types, and you might think why, Robert says that these genes have typical low infection types. What a big deal. Is that important? Well, it can be important when we're looking at gene combination lines like this one. All right, so let's just say, for example, that gene A gives a low infection type of a fleck or a naught fleck like this. And let's just say that gene B gives us a 2 infection type like this, right? So where we have the A virulence of pathotypes on gene A, we're seeing a naught fleck like that. And where we have the A virulence on gene B, we're seeing a 2 infection type like that. And I took you through an exercise like this the other day when we went through with leaf rust with the genes LR1 and LR20. So let's see if you can predict what the genotype is going to be here. So here we have a pathotype that is A virulent on gene A, right? A virulent on gene B. And when it's put onto a differential line or a line carrying both of those genes, what will be the infection type here, do you think? All right, this was the law, the host pathogen, the genetics of host pathogen interactions, law number 2. When you have 2 resistance genes together and a pathotype or an isolate that's A virulent on both, you will always see the one giving the lower infection type. So in this case here, 2 genes together, one giving a naught fleck, one giving a 2, with a pathotype that is low on both, you're going to see that lower of the 2 infection types. Oh, just gave you the answer. I should have asked you to guess that one, but you can see what's going on here now, right? We've now rendered gene A ineffective, and what we're going to see now here is the effect of gene B, which is it cause a 2 infection type. It's going to look like that. So this differential 3, depending on what pathotype we use, it could look like that, or it could look like that, or it could even look like that. All right, next one, naught fleck, of course, and the next one, 3+. So there you have a single differential, a single wheat variety, and the low infection type has changed depending on the virulence of the pathotype that's being used. Okay, so again, the reason that I'm mentioning this to you and stressing the importance of this is that some of the differentials we use carry more than one resistance gene. And you say, well, we should be using differentials that only carry one gene, but despite our best efforts to develop differentials carrying single genes, often you end up, well, I shouldn't say often, but sometimes you end up with another gene in there. And when you're testing those lines, you'll see a change in the infection type. If you know the genes and you know the low infection types, you can usually work out what's going on. So the fact that there's more than one resistance gene in a differential doesn't mean that that differential is any less useful, provided you know what you're doing. Okay.